Okay, let's jump right into this explainer. Today, we're completely decoding Cambridge Additional Mathematics 0606, specifically diving into arithmetic and geometric progressions. But here's the twist. We aren't just looking at the raw math itself. We're actually looking at it directly through the eyes of an examiner. We're going to crack open the examiner's playbook so you can see exactly what separates a pretty good answer from a totally flawless one.
Now, you might be wondering why focus so heavily on progressions. Well, honestly, it's a massive pitfall for a lot of students. Principal examiner reports consistently highlight that recognizing arithmetic and geometric progressions and really fully understanding the fundamental differences between them is just incredibly misunderstood. But don't worry, today we're extracting direct insights from those very reports to show you exactly how to master this topic and lock down every single possible mark. To keep things super actionable, we're breaking this down into 5 quick sections: examiner warnings, assessment principles, procedural framework, method mark strategy, and finally the critical analysis mindset. Think of this as your foolproof strategy for tackling literally any progression question they throw at you. All right, let's jump straight into section 1, examiner warnings, and take a look at the absolute top mistakes found in candidate papers. Straight from the people grading your papers, examiners report that students consistently bleed marks because of 3 main culprits. First up, confusing cause and effect within the progressions themselves. Second, completely forgetting to check their format and presentation. I mean, things get messy, and the mathematical logic just gets completely lost on the page. And third, giving generic answers that ignore the specific context of the problem. Like, if a question gives you a real-world scenario for a geometric progression, your final answer absolutely has to reflect that specific scenario, not just be some random floating number. So how do we avoid those exact traps? Well, we move to section 2, assessment principles. Let's talk about what examiners are actually trying to test when they design these questions. Basically, every progression question you face is built to test 3 distinct cognitive domains. Slice 1 is your foundational knowledge and understanding. Do you actually know the core formulas? Slice 2 is application. Can you use those formulas practically? And slice 3 is analysis. Can you dissect a really complex problem and figure out which progression even applies? You absolutely need all 3 to succeed here. The ultimate goal the syllabus is pushing for is connectivity. Top-performing students don't just memorize things. They show a deeply connected conceptual understanding. Why is that a real game changer? Because it makes your knowledge completely transferable to unfamiliar contexts. When the exam suddenly throws a totally weird, never-before-seen scenario at you, that connected understanding ensures you don't freeze up. You just seamlessly apply the principles you know. So let's look at the actual execution in section 3, the procedural framework, which outlines the strict conventions required for systematic processing. Your presentation on the page has to follow some pretty strict conventions. We're talking about proper headings, using the exact correct mathematical terminology, choosing the appropriate formats, and leaving incredibly clear annotations. Think of this as your professional blueprint for how you extract and interpret data. It signals to the examiner right away that you are disciplined, logical, and highly systematic. To actually build that discipline, you'll want to follow this standardized 5-step sequence. First, identify the key elements of the progression. Second, apply the relevant mathematical principles. Third, execute your analysis with really clear working. Fourth, verify your results, like take a second to ask, does this answer actually make logical sense? And finally, present it all in the appropriate format. If you stick to this sequence, you're guaranteeing a logical flow that is incredibly easy for an examiner to follow and, more importantly, to reward with points. And that brings us perfectly to section 4, the method mark strategy. Seriously, pay attention here because this is your absolute ultimate exam lifeline. So what exactly is it? Well, method marks are awarded for demonstrating the correct procedural process. That means you literally get credit for your methodology, regardless of any silly math errors that might pop up later in your calculations. If your logic is sound and visually clear on the page, you're scoring points. It really is that simple. Now, here is the most crucial, explicit alert that examiners are basically begging you to hear. Students lose so many marks simply by not showing their working. Even if your final calculation is entirely wrong, maybe you just dropped a negative sign somewhere in the rush, method marks can literally save your overall grade. Showing your work is an absolute non-negotiable step in the examiner's playbook. Do not skip it. All right, for our final piece of the puzzle, section 5, the critical analysis mindset, focusing specifically on how top-scoring candidates actually think.
Top candidates don't just act like human calculators. They demonstrate what we call evaluative thinking. This means they're actively questioning assumptions, considering different perspectives within the problem, and firmly justifying every single decision with solid mathematical evidence. They never just state an answer. They prove exactly why it has to be the right answer. To pull this off, they rely on a really powerful deconstruct, solve, evaluate method. They systematically identify the given info, break it all down into logical steps, solve it systematically, check it for reasonableness, and then make justified recommendations. It's essentially a foolproof way to break down any terrifying word problem into totally manageable, logical little pieces. This methodology gets particularly interesting when you're asked to compare things. When dealing with comparative analysis between arithmetic and geometric progressions, you can't just define what they are. You have to explicitly identify both their similarities and their differences. That means using appropriate comparative connectives, supporting each point with hard evidence from your calculations, and drawing firm conclusions about their relative importance in whatever context the question is asking about.
Now, I know that is a lot to remember when you're under the pressure of an exam clock, so here's a brilliant little memory hack for you. Before test day, take the first letters of those key framework terms we just discussed. Identify, break down, solve, check, recommend, and create your own personal mnemonic. Locking in this methodology means you absolutely won't freeze when you open that paper. Your brain will just automatically trigger the right procedural steps.
So I want to leave you with this final thought. When you finally sit down for your Cambridge 0606 additional mathematics exam, are you going to rely entirely on raw calculations and just pray you don't make a single arithmetic mistake? Or are you going to secure every single method mark by making your logical process undeniably clear to the examiner? Next time you face a complex progression, just remember this playbook. Show you're working, apply the systematic framework, and always justify your analysis. Doing that won't just improve your math, it's going to maximize your marks.